Hello and welcome to Chapter 7 on sampling. Sampling is how we go about gathering our participants for a study. And while it's important for all data collection, it's a particularly important issue when you're doing survey work, since the purpose of survey work is to get an idea of the lay of the land. If you don't have a random sample, if you don't have a representative sample of the population, then you're not going to have a good understanding of this lay of the land. So the ideal goal, particularly for surveys, is a representative sample. The practicality is, though, we don't often have proper random samples. We want to make sure that we have a good understanding of the distinction between populations and samples. A population is the collection of all persons, animals, objects, whatever it is we're studying that we want to learn more about. And usually, and your book does not make a big deal out of this, but it is a subtlety that matters. They have at least one thing in common, one thing that holds them all together. Now, there's an incredible variety of these things that can be incredibly large groups. A listing here, you can get a sense of relatively large and relatively small populations. All humans, very large. All Americans, still very large. All college students, very large. All FSU students, oh, well, a largest number, but it's actually a number you can imagine actually getting data from each and every one of them on. All big cats, okay, well, that's a lot of big cats. All tigers, that's still an awful lot and hard to figure out how you get access to data on all of them. All counties in Maryland, all businesses, and all fast food franchises. And as you run through each of these in your head, you can imagine impossible to get at everything versus in theory I could get at every one of them if I had to. Like all counties in Maryland. Well, there's not that many. It's not a tiny number, but you can certainly imagine contacting and getting data from every county in Maryland if you needed to. A census is when you measure an entire population of interest. That is, you've gathered data from each and every member of the population. This is very difficult to do. We're mandated by law in the United States to gather a census to count all of the people who are citizens or residing in the United States every 10 years. It's an incredibly difficult job. And we know that we can't count everyone. During the process of doing the counting, people move, people are born, people die. And so, no matter how tight a time limit you form on doing the counting, it is obvious that it is impossible. The question is, how good a job can you do? And that's always a point of contention as to how to do the best job of doing that census while recognizing the impossibility of doing it perfectly. A sample is a subset of the population, and almost all research is done with samples, with a few exceptions. How that sample is obtained, how we go about getting that subset of people, is closely related to a notion of representativeness, how representative the sample is to the population that you're trying to get an understanding about. What we mean is, does it have a similar distribution of individuals' characteristics, particularly on the stuff you're studying, compared to the population? We see them in similar proportions. Representativeness is what allows us to make statements of generalizability, that we can generalize from our sample to persons that we did not directly measure in the population. If I measured 1,000 people, can I know for sure that the many tens or hundreds of thousands or even millions of people that I did not measure, we still have an understanding of, even after measuring only 1,000 people? And the answer to that question is, if you did a good random sample, yes, we actually do have a good idea of that. We can generalize if we used good methods, and that's what's hard to pull off. What we're saying with all this about generalizability and representativeness is we're trying to describe validity issues, specifically external validity. External validity is high when we have a representative sample. High relative to a population of interest, though. If we're trying to do a study of FSU students and we gather a sample of say 50 of them, and they're a good random sample and they're a good representative sample, we can say we have good generalizability, we have good external validity to FSU students. We're not trying to say we have good external validity to all students in the United States or all college students in the world. Only about FSU students. So it's always external validity is described in relation from the sample to the population that you have defined your interest as being in. If the sample is biased or non-representative, then external validity is low. That is to say, generalizability is low. Biased means that the method of gathering the sample means that some members of the population have a higher chance of being in the sample than others. Biased is a very important word to make sure you get the jargon definition in the world of psychology well understood. When we're talking about bias here, we're not talking about the kind of mean-spirited kind of bias associated with stereotyping or racism or sexism and that kind of thing. What we're talking about in terms of bias here is from a statistical or research perspective, we have not gathered data so that we have a good representation of all the possibilities of what can be in our can be included in our research. We have accidentally or possibly on purpose because of constraints on design made it so that certain persons are more likely to be in our study than others, and therefore our research is going to tend to tell us more about those persons and less about the other persons. What we strive to do is use sampling methods that ensure that we have representative samples so that we have high generalizability, high external validity, and particularly we want to do this for surveys because the fundamental idea of a survey is simply to give us an idea of what's the lay of the land, what's a picture of what's going on in the world. And because that's its goal, if you don't have representativeness, then you never really took the picture you thought you were taking. You can't really say what you think you understand. There's two general classifications of samples. Probability samples. These are sampling methods in which the chances of each person being in the sample can be determined or well understood. And by the way, I'm going to tend to talk about people, but it could be any object of interest. It could be counties, in which case this would be rephrased as each county in the United States being in the sample can be determined or well understood. It could be cars. Each car in a given delineated area has an equal chance of being included in the sample, and so forth and so on. Random selection methods are involved in any of these probability samples. There's some kind of, if not literal dice rolling, effective dice rolling going on. Non-probability samples, much more common, there's no random selection involved. And that's not to say that they're invalid methods, but we have greatly limited our ability to make certain kinds of external validity statements when we have a non-probability sample not using random selection. Our simplest and best way to get a good representative sample is simple random sampling. It's a method that ensures that any sample selected has an equal probability of being gathered as any other sample being selected. Now, notice I didn't say every person. I said every sample has an equal chance of being selected, an equal probability of being selected. This is a mathematical nuance. In point of fact, the way you make sure that every sample has an equal chance of occurring is by making sure that every individual member of the population has an equal chance of being selected. If you have that happening, then the real mathematical constraint of every sample having an equal chance of occurring is satisfied. And it may be strange that we phrase it this way. It's just one of those things we have to deal with. Another random sampling method is systematic random sampling. It comes with a little risk, but it gives us a great deal more ease in making it happen. If we can identify the individuals in some way that's not related to what we're measuring, then we can use this method. For instance, maybe we use an identifier like their student number. We're trying to get a hold of 50 students that are representative of Frostburg State University's student body. And then we select every nth person. Now, when we say nth, what do we mean? Well, that n, that is the population size divided by the sample size. So if we have a population size of 5,000, an approximation of the size of FSU student body, and we have a sample size of 50 that we're interested in, then 5,000 divided by 50 is 100. And so we would select every 100th person after listing them by their student number identifier. Now, this sounds like this ought to work really well, and it can, but it is a little risky. And the reason it's a little risky is even though we should have reasonable confidence that something like student number is not related to some personality characteristic or grade point average or any number of other kinds of things about a student, the fact of the matter is we can't be 100% certain of that. And therefore there's a risk that there's a lurking bias in the method. Nevertheless, this is an attainable method and is often used to get a pretty good random sample, and few people will dispute a decently constructed systematics random sampling method will yield a good representative sample. Stratified random sampling is done fairly often, especially in large national surveys. It's increasingly done in political polling and other kinds of opinion polling. This is when you have known subgroups that have a certain representation that's known as proportional. This is often done with race or socioeconomic status. Another way to do it could be based on religion. Let's suppose we are doing a study of religion, and I might want to ensure that my sample represents the many religious orientations in proportion to their known occurrence in the population. What I do is I randomly select persons by some method within each group until I've gotten the right proportion. Now I'm going to put up a table, and it's quite dense in information here. But you'll notice that there are a variety of Christian faiths, there's a variety of unaffiliated faiths, and there's a variety of other religions. And this is based upon a really good poll of the U.S. population done a few years ago. And we see that, for instance, evangelical Protestants are represented as 26% of the population. Mormons represent 1.7%, other Christians 0.3%, atheists 1.6%, Buddhists 0.7%, and so forth. And so we have a variety of proportions expected. And let's suppose we're going to be getting a sample of 1,000 people. And getting that sample of 1,000, if I want to ensure that I have a proportionate representation of all of these religions, what I want to do is make sure I get a certain number of people that have these affiliations in that they let us know about. And so I want to get 263 evangelical Protestants. I want to get 69 persons that have an affiliation with black churches. I want to have 3 persons that are of other Christian faiths not listed in that list. I want to have 24 agnostics, and I want to have 6 Muslims. Now this can be very effective. This can generate a very good representative sample. But you might be intuitively getting a little antsy about it as you look at it. The 263 evangelical Protestants certainly sounds like a reasonable number to get some sense of what the attitudes of evangelical Protestants might be. But I'm going to sample only 4 Hindus, and somehow I think I'm going to have some understanding of what Hindus' attitudes might be on something. Well, if it's representative, we're going to trust it. But the fact of the matter is I think we all know that we get to very, very small numbers, the chances of our our sample not really giving us a good snapshot kind of increase. And so we have a way of handling this called oversampling. Oversampling is usually done in concert with stratified random sampling, and it is a way to ensure that rarely represented groups, such as I was talking about a few moments ago, have an adequate sample size. That is, instead of sampling, say, only 4 Hindus, I might sample 40 of them. Now that's way more as a proportion than I would expect to see in my total, in my population, as a proportion of my sample. But what I'm doing is making sure I gather enough people that I get a good idea of the range of attitudes or ideas or whatever it is that I'm after in my study. And then afterwards, I can statistically adjust their impact. I can change their weighting in the final data. So they only weight as much as the 4-person should be, but is still representing the entire range of possible responses. This is a clever way of handling the problem of relatively rarely occurring individuals. Cluster sample is another potentially random sampling method. What we do there is we're using naturally occurring groups in a population. And by doing those, getting a hold of those folks, what we're doing is instead of randomly obtaining the individuals, we're randomly selecting the clusters and then taking all the individuals who are in the cluster. Maybe we're interested in the characteristics of students in the nation. And what I'm going to do is I'm going to randomly select classrooms and gather data from all of the students in a given classroom. This can be an effective way to get a random sample while not putting myself in the position of going from room to room to room around the country, getting 1 and 2 students out of a room here and a room there, and 2 or 3 schools in this city and 5 or 6 schools in that city. What an incredibly laborious situation that would be. If I can get nearly as good a representativeness by getting all the students in a given classroom and doing that with about 100 classrooms around the country. Quota sampling is a non-random method. And as soon as we get into non-random methods, we're getting into generally lack of representativeness. It comes with problems. We can't really trust our data nearly as much then. It's similar to stratified sampling in that subgroups are identified and the proportion of people in the population is matched. But the key difference is no attempt to randomly obtain participants is done. You're simply going and getting folks that are convenient or happen to volunteer or otherwise we have access to, but not by any kind of random method of obtaining them. Quota sampling is not uncommon. That's another way of saying I don't want to say it's common, but it's not so rare that you'll never see it. It happens. Convenience sampling is selecting those that are conveniently available. It has poor representativeness of the population, but it is extremely common because it is so inexpensive in time and money. What you're basically doing is finding the people you can get a hold of and using them in your study. I want to learn a little bit about how people feel about shopping in the current era, given the recession we've been going through. I go up to the shopping mall here in Cumberland and I ask people questions. Well, they're convenient, but I'm not necessarily going to learn much about national trends, am I? I'm going to learn maybe, not guaranteed, but maybe something about folks who live in Allegheny County. Well, that doesn't even sound that good for that, does it? Self-selection sampling is similar to convenience sample in that it is also easy and often done. What you're doing is relying on volunteers, people that are interested in being in studies in general, or in your study in particular, or maybe there's a reward system that is motivating them to volunteer to be in the study. This is very common in psychology research because of the expectation that you will have running studies with volunteer students from Psych 150 classes, equivalent to Psych 150 classes at colleges around the country. It is commonly done that such classes are used as subject pools, participant pools for research. They're given extra credit in their class for having participated in the study. And so what you have is folks that are willing to volunteer to be in a study, and they're getting a reward for it. Their investment in being in the study can be highly variable, and their representativeness, obviously, is potentially quite poor. Number one, they're students at college, which that's not all the population of the country by any measure. Furthermore, they're the ones that are taking a psychology class, and that's not necessarily even all college students. And so you have real issues with the self-selection sampling, and this actually has some connection to convenience sampling as well, and that it's usually poor in representativeness. And a large amount of online polling is also self-selection sampling, making it pretty much useless. You put a poll up on the internet, and what you do is you do a lot of people contacting friends and folks coming in and doing the study for whatever reason and being in the poll, and you really don't get a sense of what the real population interest on the issue is. It can have some real problems for you. I was doing data collection for my dissertation. Actually, it was prior to my dissertation. It was a pre-study we were doing before it, and we were testing out some new equipment to see how well it worked. And what we did was we put an ad in the newspaper, as we usually did, and we were get volunteers from the community. Now, obviously, this is a self-selected group of people. We know we're not necessarily getting representativeness, though you would be surprised how good it is. In my dissertation, we did not actually deviate much from the census values for Salt Lake Valley using that kind of volunteer method. With that said, we noticed a certain trend because we would always debrief folks afterwards, and one of the things we would ask them is what their employment was. And we wanted to do this because we wanted to make sure we weren't accidentally getting people all from the same place, and lo and behold, we were. We started getting an awful lot of people who had jobs at restaurants, and we finally started asking questions, what restaurant is this? And within a day or two, we realized that one person had come and done the study from a restaurant, and we're paying like $50 for them to be in the study. And so suddenly we had all the dishwashers, all the other wait staff and cooks and everyone else at this restaurant volunteering to be in our study. It didn't ruin the results of the study, but it made it so that when phone calls were coming in to participate in the study, we would ask if they were at that restaurant, and we were not allowing any more people to come from that restaurant. Purpose of sampling is when you've done an identification of people who have been subjected to some unique conditions that are relevant to the purpose of the study, and you want to get access to them and measure them. Maybe they're persons who got a new training method, and it just happened, and you want to see if it had some effect on how productive they were on the job. Or maybe it was a situation where a natural disaster occurred, and what you want to do is go find these folks and learn about how they've recovered from the disaster, how they dealt with it, and so forth. And so you've got to wait for the opportunity to come. This is, again, not a random selection method. Snowball sampling is a particularly interesting one because even though it's not random in selection, it may be the only way you can get data on certain issues. When you find an individual, what you do is you ask them to tell you about other individuals that they know have the same unique, relatively rare status that you're interested in studying. What you're trying to do is get them to snowball up. They tell you one or two people, you go and talk to them, you get data from them, and you ask them to tell you about two or three more other people. And like rolling up a snowball, you're building up your sample through this string of contacts that expands outward. And eventually you get to a reasonable collection of people. And for populations that are difficult to locate, that are secretive because of whatever habit it is that you're investigating, maybe it's drug use, maybe it is you're interested in the attitudes or behavior of sex workers, or a rare condition that people don't talk about much in terms of a medical condition. It can be one of your great ways to get a hold of people, because often persons who are in these relatively rare circumstances know others who are in the relatively rare circumstances. So, when does external validity matter? Always? Well, if we could, it'd be lovely to have great external validity always. That is, a great representative sample. But the reality is, good, simple, random sampling of useful populations is very expensive. If I wanted to do a simple random sample of the students in my classes, that'd be easy. If I wanted to do a simple random sample of students at Frostburg State University, it's doable, but it would be tough. If I want to do a simple random sample of students at universities around the United States, that's going to be really expensive. So for surveys, you do the best you can, and they are pretty good at it. They use random telephone dialers and random email methods now, and they're able to get a hold of a variety of people and take into account certain census data to do stratification and weighting and other things. They're able to make it work, but it's tough. For surveys, it's vital, or at least very important, so you can get a real statement of the lay of the land. So you want external validity on surveys in particular. But what about other studies? What if you're just interested in measuring the association between some variables? or maybe you're trying to detect a causal relationship in an experiment. External validity is actually not that important for making those claims. I don't need external validity to say that in my study two variables related to each other. I don't need external validity to be able to say that there's a causal relationship found in my experiment. I do need external validity if I want to say that causal relationship or that association that I've spotted somehow is what I expect to see in other persons that were not tested in my study. So I do need external validity for that. But to make my basic claim of association or causality, I don't need external validity. And this is very important because it's one of the things that students intuitively gravitate towards is sampling issues when they're talking about limitations in their studies. And while sampling issues are certainly there, if they don't, they may not really address the key issues of what the study's trying to claim or find. So when does external validity matter? When we lose external validity, we lose the ability to say that the association is known to apply to a broad population, as I was just saying. The relationships are unaffected by these weaknesses in sampling or external validity. But we can get there. Eventually, we can get external validity. We do subsequent studies with different samples, a variety of studies that capture different situations, different populations people are sampled from. So maybe the study is done here, it's done in California, it's done in the southern states, it's done in the northern states, it's done in Canada, it's done in Europe, it's done in Africa, it's done in Asia, it's done in South Asia, it's done in wealthier parts of Asia, in South America and Central America and so forth. And eventually, if you do the study, and it takes decades sometimes to do this, and you keep getting the same results around the rest of the world, then you can start saying, hey, you know what? This applies to everybody, not just college students in the United States. So you can build up external validity, but you're going to have to take time to get there usually. Larger sample sizes are preferred, but not for the reason that you may intuitively think. Larger sample sizes increase what we call statistical power, which is the ability to spot what we're looking for in our study. But larger sample sizes have nothing to do with representativeness once you get past a handful of participants. You may remember earlier I was talking about how we feel like we need to have more than just 2 or 3 or 4 people, say of Hindus or other relatively small populations of people. Yes, we're going to have difficulty trusting the representative of 3 or 4 or 5 people. But once you get past about 10 or 15 or 20, you probably are getting a reasonably good variety of folks. And I know you may be going, wait a minute, that's just not possible. If they're randomly drawn, while you may not be getting the most extreme variations in there, you probably are getting a pretty good sense of the lay of the land, even with that few people. Larger samples have nothing to do with representativeness. I can't say this enough. But, so it doesn't matter how big a sample is, or how big the sample is compared to the population. That's another thing that's difficult for people to understand. How is it possible that a sample of only 1,000 people can tell me about the attitudes of the entire population of this country, as we often see in political polling? Well, because if they're a properly drawn random sample, they are going to tend to be representative of the entire range of responses of the country. That doesn't mean, that means I don't have to ask each individual person to get at a good idea of what the broad variety of issues and ideas and attitudes and thinking is in the country. So it doesn't matter if that sample of 1,000 is coming from a population of 10,000 or a population of 10 million. The 1,000 will be just as good in each case. So to summarize today, representative samples are most important when making frequency claims about populations. That is, when we're doing survey work. It is best to use probability sampling methods to ensure representativeness. But for association and causal claims, samples that are representative is less important. Nice to have, but not important for the claim that you're really after, which is the association and causal claim. Sample size has no bearing at all on representativeness, even though our intuition strongly makes us want to think that it should matter. And imperfect sampling is common, creating limitations in our studies, but it shouldn't stop us from doing good research. We're going to have imperfect sampling in a lot of our studies. That's just the nature of the beast. Next will be in Chapter 8. I thank you for your attention. Goodbye.